we're a smart tire company, and we started developing tires for extraterrestrial applications. So we have a lunar tire here and a Mars tire here, and you can see the tire is compliant. So if you look at the original tires for Mars, this is a mock-up of the tire, and when the tire was on the surface of Mars, they were trying to go over the very smooth areas, and they found out that the vehicle sunk into the smooth areas. And so when they got the vehicles back out, they had to go to other areas where it's rockier, so that the vehicle wouldn't sink. So in this tire is, if it on Mars, would be one millimeter thick aluminum tube, right? And when you go over rocks, then you have point contact on the 1 millimeter thick tube, and you punch quarter-size holes in the tire. So that's the failure mode for the tire. So to solve that problem, we've been developing with NASA. We're developing the spring tire, where basically it's compliant, and I can put any kind of hole you want into it, and nothing's going to happen to it, right? When we tested this tire, we got under really rugged conditions, and it was spring steel. We tried to destroy the tire, and we were somewhat successful at destroying the tire. We kinked the sidewall, so we got permanent deformation of the spring steel in the sidewall. So a friend at NASA introduced me to shape memory alloy. So this is a spring just like you would have inside that tire, and it can take 80 times the strain of normal steels. So I can bend this like that, and if I did this to a normal steel, it would stay kinked, right? And you can see it does nothing. And so we started using this into the lunar application and the Mars application, because the material is really almost indestructible. And then we got to the point where when we're doing our testing, we were actually wearing out the rocks that we're testing over, and the wheel was almost virtually pristine. So this was kind of this shape memory alloy was the engineering breakthrough to make all this successful. So
what's the difference between these two wheels? Because I see a little bit.
Okay, so when we started making the first tires that we built were what we call radial elements, which are these elements that go from one side of the tire to the other side, bead to bead. Okay, and when we did durability testing, we bent these. Okay, thus the next step was to move to this stage where basically I no longer have that straight element, so I have something that can give more, and that's the invention of the spring tire. And then when the shape memory alloy came, and the limitation for the spring tire was always load carrying capacity. But when the shape memory alloy came about, now I have a tire that has radial elements. I went back to where I started, right? Now I have a tire that has radial elements like that one, right? And then the springs are weaved around it. So now I've significantly increased my load carrying capacity. So this tire would be this Mars rover tire. This would be like a 60-pound load per tire, and we're going back to the moon. So you're going to have astronauts and all their gear. So you're going to have a vehicle that's going to have much heavier. And so this is like a 650-pound per corner tire. So that was, again, this shape memory alloy was the enabling material to make all of this work. So once we had that, the next thing is, all right, it works in space, why don't I bring it to an Earth application? So you basically just take this spring and you blow it up to give it a bigger diameter. Okay, you have a slinky made of shape memory alloy, and that shape memory alloy we put into bicycle tires.
Let's go over there and check it out.
So if you look inside this bicycle tire, you'll see this slinky essentially inside the polymer, right? So this tire has no air, and you can put as many holes in it as you want, and you can still ride on it.
It's all SMA.
So the structure is SMA,
That's
right?
an expensive tire.
So, no, it's actually, if you look at the filament diameter, it's getting very small.
Really?
And so it's all about mass.
It never get flat.
Never get a flat. So if you'll go to this other one,
Yeah, let's go check it out.
you can actually see a cross section where you see the slinky, right? The shape memory alloy, and then the polymer, and then we're bonding on a tread. And this is the biggest hole that you could ever imagine, right? And you still have load carrying capacity, all right?
What's it weigh, grams roughly?
So we're developing. So that is the front tire is very close to the same weight as a gravel bike tire.
Okay.
We're slightly heavier, but it won't be long before we're going to be commensurate with the weight. We're also kind of changing the way the business model. So we're bonding on a tread with thermal glue. Okay, and when you wear out the tread, instead of throwing out the whole tire, you heat up the tread. Okay, you debond the glue, snap another one on, because all this is a rubber band, right? Snap another one on, heat it up, and when it cools back down, you've retreaded the tire.
What's your target retail price per tire?
So we're talking about $110, $120 a tire.
Similar to a Continental.
Exactly.
not bad.
Exactly.
Yeah, I can't wait for it to hit mountain bikes.
So, yeah. Well, this is not really far from a mountain bike tire already.
You get gravel bikes.
So, and then we're also doing.
Let's go there.
So you can see the core structure, like if you were going to put this on a carbon fiber rim. We're also starting to work with smaller micro mobility stuff,
Wheelchairs.
scooters, anything really. Yeah, so we're doing micro mobility stuff, and you can see it's basically the same structure that's inside the rim. And this one is shown without a rubber tread applied to it, but we're going to use the same technology you saw on the gravel bike, so that you can retread these just like you would a truck tire.
Yes.
How far away are you from like a vehicle, like a road-going vehicle?
I think we'll
Couple years?
probably be in production with the bicycle tires next year.
But like cars.
So
How far away from cars?
I'm not going to give you a date on that.
Because you still have to overcome the weight restriction, the load-bearing weight involved with the vehicle.
Load carrying capacity. It's going to not look like this,
Yeah.
an automobile tire. I don't see load carrying capacity being a problem at all. So yeah, we're working our way there. There are
Nice.
drawings already. So
Well, I
there
can
are
see
designs.
I can see Jeep guys loving this for off-road capabilities.
Yeah.
Because that's where you pop a wheel.
Yeah,
Pop a tire.
and ATVs,
ATVs, I have
right?
one, yeah.
So or side by sides.
Absolutely.
So yep, and the military vehicles.
I'll have to give you a call when you get those running.
It's cool stuff.
If they needed to get in touch with you, where would they go?
It's a Smart Tire Company, and I can actually give you a card.
Got a website? That's the website, Smart
Yep.
Tire Company? Yeah, here we go.
Or they can probably just scan this QR code and get
There
more
you are.
information.
Yeah, there you go. Cool. Well, thank you for the awesome interview,
Thank
Jim.
you.
Yeah, check them out, guys, if you guys want to learn more. We got hello@smarttirecompany.com or smart.tires. Very cool. Thanks a lot.
Thank you. Nice talking with you guys.
You too.